Hi there. In the next series of lectures, we're going to get into a new topic in Java known as multi-threading. So to better understand this concept, I'm just going to give you a little bit of background information before we get into the details. When you're using your computer, you often have multiple applications running, and they're usually running at the same time, right? Some of these applications you may be aware of, and others may be behind the scenes, right? Let's consider a typical example of a user browsing the internet using the Chrome or Firefox browser. While the user is browsing the internet, they may also have a music player running. Both the music player and the internet browser are applications running at the same time. Behind the scenes, there may also be a virus protection software scanning your computer for malware. These three applications can also be referred to as processes. Three independent processes running at the same time. Now, there are usually a lot more processes running on your computer behind the scenes, but these three, let's just consider these three in this example. Now, within each process, there could also be lighter weight child processes. Let's take an example of the internet browser applications such as Chrome or Firefox. A user could have multiple Chrome or Firefox internet tabs open, right? One of the tabs could be playing music from YouTube, and the other tab may be refreshing their Gmail inbox, and another third tab may be refreshing a Facebook feed. All of these browser tabs work simultaneously within the parent process, okay? So these you can consider these child processes, the different tabs that you have open. Now, in computer science, these child processes are also referred to as threads. Okay? The various programs that we've been writing in this course so far, right, these Java programs, they've so far only been single-threaded programs. In other words, at any given point in time, there was only one thread or one task really, and that thread was known as the main thread. Now, I'll go over the main thread in just a minute, but within this main thread, instructions were executing sequentially one by one. And what were these instructions? These were those lines of code that you've been writing. When one line of code would complete running, the next line of code would execute, and so on. This is a single-threaded execution. At any given point in time, only a single line of code was executing. But you can also write multi-threaded programs, and you could probably guess what that means. This typically means that two or more lines of code can run at the same time. For example, you could write a Java application that is downloading files from the internet and performing statistical calculations on that data, and loading a summary file into a database. These are different tasks, and each one of these tasks can be running on their own thread of execution. Okay? And all of them could be running at the same time. One thread can be responsible for only downloading the files from the internet. Another thread could be, creating those files to load in the database. And the third thread could be responsible for reading data and performing calculations. All three of these flows of the program, these tasks, these three tasks, could be happening at the same time, and which would mean that multiple lines of code are being run simultaneously. All right, that's the core of multi-threaded programming. Multiple lines of code running at the same time. All right. Now, writing multi-threaded programs can be a challenging feat and often takes many iterations of refactoring the code over time, to build a stable application. And the complexity here arises when threads need to communicate with each other. Deadlock situations can occur where thread A is waiting for thread B to complete. However, thread B is actually waiting on thread A to complete. This will all make sense when we go into the details of some of these messy scenarios, and I'll go over that in great detail in this in the remaining lectures. But for now, let's go over how to start a thread in Java. So here we are in Eclipse. I've created a project called Learning Threading. So you can go ahead and do the same. And I have a package here called com.jobready.threading, okay? And that's just the naming convention that we spoke about earlier, where we have this com followed by your company, followed by the kind of thing that this package contains, and we're going to be learning threading, so that's what I called it. And in here we have a class called application. So let me show you how to create your first thread in a Java program. I'm going to define the public static void main method here, and inside of this method I'll have a simple print line statement that just says hello there. Doesn't really matter what we have there. But now if I hit the play button, we would have started a thread, believe it or not. So let's hit play. There you go. It says hello there. We actually executed a thread, and that was the main thread. Main method starts everything, and what it is it starts a thread. Now within this thread, so far in this course, you've been writing all of the code inside of main, and sequentially, line by line, it was being executed, right? Even if we were involving multiple classes, that code was, being utilized here in this main method because it's executing line by line. Meaning at any given point in time, we were only having one line being executed, right? One after the other. But how do we get two lines to run at the same time? That's where multi-threading comes in, right? So at this point, we're single-threaded, but now let's make this multi-threaded. Outside of this class called application, I'm going to define, within the same file, I'm going to define another class, let's call it task. And that's what I want you to start thinking about, is this task-driven mindset, especially when it comes to writing multi-threaded programs, because a thread is essentially a task. I want you to think of that as a task, and a task has steps that need to be executed. So I created this class called task, and it's going to extend the thread class. Okay, and this class has been around since Java 1. Right from the early days of Java, Java was multi-threaded, and that's one of the competitive advantages Java had right from the start. So if you go to the definition of this thread class, I'm going to control click it. Notice that this is a class that implements runnable. If we go into the runnable interface, it has this method called run, and it's an abstract method. So to create a thread, we need to override this run method. So since this thread class is implementing this runnable interface, it must have implemented a version of the run method within the body of this class, right? So let's look for that. I just want to show you. If you type in run and then you put parentheses, and it's a void method, so it doesn't return anything, I'm just going to put that as the signature, and let's search for that in this class, and there we go. Notice that this is that method. It's being overridden. In this thread class, well, we're actually also going to override it. So this new class that we defined called task is actually going to have its version of run, and that's the guy that's going to be executed on a separate thread. So let's create that method. I'm going to do public void run, and in this method all I want to do is just create a loop to print some data. So it's just going to be a for loop, and we're going to initiate the variable I for iteration. We initialize it to 0, and then I is less than 1000, and I++. And in this loop, I'm just going to print out the value of I. Okay, so I'm just going to write the word number with a colon and just append the value of I to that. And now when I run this program, what do you think is going to happen? Right? We haven't done anything really. We're defining this structure of what a thread is. We called it a task, and we gave it the instructions, but we haven't kicked it off yet. This is still a single threaded program. If I hit play, this is still a single threaded program. Only the main thread gets run. So let's create an instance of task, which is essentially a thread, right? It's extending the thread class. It is a thread. That's what I want. That's how I want you to think about it. So let's create an instance of task, and the object name is task runner. Is new task, and even to this point, this is still a single threaded program, right? What we have to do is you might be thinking that we need to invoke the run method, but that's not what you do. You actually have to invoke a method called start right here. And you can see that this causes this thread to begin execution. So this is the guy that we want to call. And what that's going to essentially do is invoke this run method in a separate thread. So if I run the program the way it is right now, it's going to print hello there first, and then it's going to print the numbers from 0 to 1000 or 0 to 999. So let's hit play. And these are the numbers. Let's scroll up all the way to the top. Notice it printed hello there. Now let me prove to you how this is a multi-threaded program. If we move this code above that print statement. So with the previous knowledge in the course, we've only been working with single-threaded programs prior to this lecture, right? So you were aware that until one line of code isn't complete, it doesn't move to the next line, right? We wait till that line is complete, then sequentially it moves to the next line and so on. That's a sequential single-threaded program. That's what you've been working with. But in a multi-threaded program, if a new thread is spawned, it doesn't wait for that code to complete. It just says, okay, go ahead and execute this code, and it could take you an hour. I don't care. I'm moving on to the next line, and that's exactly what's going on here. Let me prove it to you. If I hit play, notice that towards the end of those numbers, we don't see that print statement. Where is it? Let's go all the way to the top. It actually executed that first. And the reason behind this is because when the interpreter got to the line where it says task runner dot start, it didn't wait until that line is completed, right? It didn't wait for all those numbers, from 0 to 999 to be printed until it moved to the next line. It just said, hey thread, start yourself. And that thread was started, and the interpreter continued to move on to the next line to bigger and better things. So the reason for why the word hello there was printed first is because it takes time for a thread to fire up, okay? To get spawned, so to speak. So when the thread was spawning, before it actually kicked off, the words hello there were printed. But if we had other things down, printing, much later on in the code, they could have appeared while those numbers were actually being printed. It could have printed something, between the numbers 55 and 100, or between the numbers 350 or 400. It could have printed other things if we had more code, because a thread is running and it's going to continue to run until it's completed. And, that's one flow, whereas another flow of code may also be running on a different thread. So that's the whole idea behind multi-threading, and this is going to make much more sense as we look at more examples. Again, just like before other parts of this course, I don't shy away from repeating myself, so I'm just going to go over this once again with you because it's such an important concept. So this is a multi-threaded program because once this task runner was started, it was kicked off, the Java interpreter didn't just wait here. It didn't wait for this to complete. It moved on to bigger and better things. It started this thread, and this thread is going to do what it needs to do, but the interpreter is moving on to the next line. And then it printed out this. So it kicked off this thread, moved on to bigger and better things, and we are here. Now you might be wondering, what if we want to run through this loop again? Could we do task runner dot start again? Well, think about it. We told Java to go on and kick off a thread, and it does this by using the start method, and the way it has access to that is through this instance variable called task runner. So the thread has been spawned and kicked off. But if we try to do this again using the same instance, it will actually fail. It's going to give a special exception, and that's called illegal thread state exception. If I hit play again, notice that you saw a little bit of red there. Let's go to the top and saying, exception in thread main. So always remember, it's never legal to start a thread more than once, okay? In particular, a thread may not be restarted once it has completed execution. Always remember that. So the solution to this, if you want this to, go through this loop again for whatever reason, and you want to do it in a different thread, the way to do that is to use this task class to create a new instance and then kick off that instance. All right. So we could do task, and I'll call it task runner 2 is equal to new task, and then use this guy to start the thread again. Well, not again, we're starting a new thread. So just like in regular object orientation, a class is a blueprint, right? A design for, that contains instructions and methods and so on. So we're just using the same blueprint of what we consider a task, which is a thread, and we're just utilizing that blueprint to kick off a new thread. So the instructions in this task, what to do, those steps, are the same as this task, but they're going to run separately in two different threads. So let's hit play and notice that now we shouldn't have that error. Another thing I want you to notice is the way these numbers are printed out. All right, let's go through this for a second. The first number printed out is 0, and then it moves on to 1, 2, 3, and whoops, there's another 0. Number 4, and there we go, we got number 1 again. Number 5, and there we go, we got number 2 again. Number 6, and there we go, we got number 3 again. So notice that the results of what's being printed here is coming from two individual threads. Okay, so this particular code is being run on two separate threads. Okay, one of the threads has been started at this line, and the next thread ends up starting here. So that's why you see those numbers repeating. They all go from 0 up to 999, and that's what you're going to see all the way to the bottom here is 999, and you'll find repeating numbers as you scroll through this. So hopefully threading is starting to make some sense. We're going to get into much more detail, and we're going to look at all kinds of scenarios that can take place in threading. So just a quick review before wrapping up this lecture. I want you to think of a thread as a flow through your program. Okay, so the first thread that gets kicked off is the main thread. So it starts off here, the JVM kicks off the starter main thread, and what that does is it looks for this main method, which is the entry point of your application, and it executes whatever's in here. So when it enters into here, it sees this line and says, oh, we need to start a thread. So it starts off a flow, so to speak. All right, and that flow is right here, so it just kicks that off, but doesn't stop there. It continues on, and it sees this print line statement, it prints that, and then it sees another thread that needs to be started, so it kicks off this thread as well, and then moves on and finishes the main thread here, while the other two threads are still running. Okay, until these don't complete, they're going to continue to run. And up to this point, the main thread has pretty much been completed, but these two other threads are still going on. Okay, so that's how I want you to think about multi-threading. Is a thread is basically a flow through your program. This first starting of a thread, right? This was the kickoff of this flow, and then the second kicking off of a thread is starting a new flow, which is also going to do the same thing, and that is why we see some of these numbers repeating. So there's a lot more to go over when it comes to threading. We're going to go into all different kinds of scenarios, but for this lesson I'm going to wrap it up here. Thanks for watching. I'll see you in the next lecture.